Acute Angels! Welcome back for another Mathenic episode. This is Mom Mika, your grade 9 teacher. Today, we will be solving quadratic equations by extracting square roots, factoring, completing the square, and quadratic formula. After going through this lesson, you are expected to solve quadratic equations by extracting square roots, factoring, completing the square, and using the quadratic formula. Solving quadratic equations is a fundamental mathematical skill that builds on earlier algebraic concepts. It introduces you to the concept of equations with variables raised to the second power, or quadratic terms, which is a critical step in your mathematical development and will help you on problem-solving strategies. Let us start with solving quadratic equations by extracting square roots. Quadratic equations written in the form x squared is equal to k can be solved by applying the following properties. If k is greater than 0, then x squared is equal to k has two real solutions or roots. For example, x squared is equal to 4. Then, the roots are x is equal to positive 2 and x is equal to negative 2. Because positive 2 squared is equal to positive 4, and negative 2 squared is also equal to positive 4. If k is equal to 0, then x squared is equal to k has one real solution or root. For example, x squared is equal to 0. Therefore, the only value of x will be 0. And lastly, if k is less than 0, then x squared is equal to k has no real solution or root. For example, x squared is equal to negative 4 has no real solution or root because there is no real number that when squared equals negative 4. Because squaring any real number results to a non-negative number. Remember these very important steps. First, solve the equation for the square of the unknown number or isolate the variable with square. Second, find the square roots of both members of the equation. Let's have some illustrative examples. Number 1, solve x squared minus 16 is equal to 0 by extracting square roots. To solve for this, we will be applying APE to isolate the constant negative 16. So we have now x squared is equal to 16, that is in the form x squared is equal to k. Next, to solve for the value of x, we will get the square root of both sides. Hence, we have x is equal to positive or negative 4 as the roots or solutions. Since k is equal to 16 and 16 is greater than 0, then the first property, which is k is greater than 0, can be applied to find the values of x that will make the equation x squared minus 16 is equal to 0 true. And to confirm if this is correct, we will be checking it by substitution. Substitute x with the values found in the quadratic equation x squared minus 16 is equal to 0. If x is equal to positive 4, then 4 squared minus 16 is equal to 0. 16 minus 16 is equal to 0. Therefore, 0 is equal to 0. Another one, if x is equal to negative 4, then negative 4 squared minus 16 is equal to 0. 16 minus 16 is equal to 0. Therefore, 0 is equal to 0. Another example, solve x squared plus 9 is equal to 0 by extracting square roots. Solution: subtract 9 from both sides of the equation to isolate the x squared term. Now, you want to isolate x on the left side of the equation. To do this, take the square root of both sides. Remember that when you take the square root, you need to consider both the positive and negative square roots. However, the square root of a negative number is not a real number. It is a complex number. The square root of negative 1 is represented as I in the complex number system. So you can rewrite square root of negative 9 as square root of 9 times square root of negative 1, which simplifies to 3i. Therefore, the solutions to the equation are x is equal to 3i and x is equal to negative 3i. The equation x squared minus 9 is equal to 0 has no real solutions, but we can express our answer as x is equal to positive 3i. Since 9 is a perfect square, then we can extract its square root and express square root of negative 1 as I. Another example, solve x squared is equal to 0 by extracting square roots. Since x squared is equal to 0, then the equation has only one solution, which is x is equal to 0. Next, a simple method we can use to solve the quadratic equation in the standard form ax squared plus bx plus c is equal to 0 is by factoring. An important technique to use is the zero product property, which states that the equation ab is equal to 0 is equivalent to the compound equation a is equal to 0 or b is equal to 0. Of course, we can only use the factoring method when we can factor the quadratic polynomial. To solve a quadratic equation by factoring, first, write the equation in the form ax squared plus bx plus c is equal to 0. Next, factor the left member of the equation. Third, use the zero product property to equate each factor to 0. Next, solve each resulting equation, and lastly, check the answers in the original equation. Let's have some examples. Number 1. Find the roots of the quadratic equation x squared minus 6x is equal to negative 8 by factoring. Solution: move all the terms to one side of the equation to set it in a standard form. So we have x squared minus 6x plus 8 is equal to 0. Now, you want to factor the quadratic expression x squared minus 6x plus 8. To do this, look for two numbers that multiply to the constant term, which is 8, and add up to the coefficient of the linear term, which is negative 6. These numbers are negative 2 and negative 4, because negative 2 times negative 4 gives you positive 8, and negative 2 plus negative 4 gives you negative 6. Next, we will factor out the left side. The quantity of x minus 2 times the quantity of x minus 4 is equal to 0. Set each factor equal to 0 and solve for x. So we have x minus 2 is equal to 0. We have x is equal to 2. And then x minus 4 is equal to 0. We have x is equal to 4. So the roots of the quadratic equation x squared minus 6x is equal to negative 8 are positive 2 and positive 4. To check, substitute the values of x in the original equation x squared minus 6x is equal to negative 8. If x is equal to 2, then 2 squared minus 6 times 2 is equal to negative 8. 2 squared is equal to 4. Negative 6 times 2 is equal to negative 12. 4 minus 12 is equal to negative 8, which is also equal to the other side of the equation, negative 8. The other root is, if x is equal to 4, then 4 squared minus 6 times 4 is equal to negative 8. 4 squared gives you 16. Negative 6 times 4 gives you negative 24. 16 minus 24 gives you negative 8, which is equal to the other side of the equation, negative 8. Example number 2. Find the roots of the quadratic equation 2x squared plus 7x is equal to negative 3 by factoring. To do this, write the equation in a standard form by moving all the terms to one side of the equation and set it equal to 0. We have 2x squared plus 7x plus 3 is equal to 0. Now, you want to factor the quadratic expression 2x squared plus 7x plus 3. To do this, look for two numbers that multiply to the product of the leading coefficient, which is 2, and the constant term, which is 3. Additionally, these two numbers should add up to the coefficient of the linear term, 7. So therefore, we will come up to the quantity of 2x plus 1 times the quantity of x plus 3 is equal to 0 as the factor form. Now set each factor equal to 0 and solve for x. So 2x plus 1 is equal to 0, and that gives you x is equal to negative 1 half. Another, x plus 3 is equal to 0, and that gives you x is equal to negative 3. So the roots of the quadratic equation 2x squared plus 7x is equal to negative 3 are x is equal to negative 1 half and x is equal to negative 3. To check, substitute the values of x in the original equation 2x squared plus 7x is equal to negative 3. So let's have first x is equal to negative 1 half. So we have 2 times negative 1 half squared plus 7 times negative 1 half is equal to negative 3. We have now 2 times 1/4 minus 7 over 2 is equal to negative 3. 1 half minus 7 over 2 is equal to negative 3. Negative 6 over 2 is equal to negative 3, giving you negative 3 is equal to negative 3. Next, if x is equal to negative 3, then we have 2 times negative 3 squared plus 7 times negative 3 is equal to negative 3. 2 times 9 minus 21 is equal to negative 3. 2 times 9 is 18 minus 21 is equal to negative 3. Next, 18 minus 21 gives you negative 3 that is equal to the other side of the equation, negative 3. The third method of solving quadratic equation is by completing the square, because not every quadratic equation is factorable. This will enable us to solve quadratic equation that is based on the general principle that both members of an equation may be raised to the same power or reduced to the same root without destroying their equality. And to do that, follow the steps. Number 1. Write the equation in the form ax squared plus bx plus c is equal to 0, where a is equal to 1. If a is not equal to 1, then divide each side of the equation by a. Number 2. Add to each side of the equation the square of 1 half the equation of x or the b to make the left side of the equation a perfect square. Number 3. Express the left-hand side of the equation as the square of binomial. Number 4. Extract the square root of each side of the equation, writing the double sign plus or minus of the number at the right-hand side of the equation. Number 5. Solve for x. And number 6. Check the answers in the original equation. Let's observe the following. How do you determine the number that must be added to the left side of the equation to make it a perfect square? Okay, let's start with the quadratic expression x squared plus 5x plus blank. To make it a perfect square, get the half of the numerical coefficient of the linear term, which is 5. So we have 5 over 2. Then square it. Therefore, the number to be added is 25 over 4 to make it a perfect square trinomial. Next, x squared plus 8x plus blank. The value of b is 8. Get the half of it, and that's 4. Then square it, resulting to positive 16. Therefore, x squared plus 8x plus 16 is a perfect square trinomial. Lastly, x squared minus 10x plus blank. The half of negative 10 is negative 5. The square of negative 5 is positive 25. So therefore, x squared minus 10x plus 25 is a perfect square trinomial. Okay, let's apply these in some illustrative examples. Number 1. Solve 2x squared plus 8x minus 10 is equal to 0 by completing the square. So here is the solution. First, divide both sides of the equation by 2 to get its simplest form. Therefore, we have x squared plus 4x minus 5 is equal to 0. Next, separate the constant from term containing x, and that is x squared plus 4x is equal to 5. Then, add 4 to both sides of the equation to make the left side a perfect square trinomial. After that, express the left side of the equation as a square of binomial or simply factor the left side. So that is, the quantity of x plus 2 squared is equal to 9. Extract the square root, which gives you x plus 2 is equal to plus or minus 3. Lastly, solve for x. X is equal to negative 2 plus 3 gives you x is equal to 1. And another, x is equal to negative 2 minus 3 gives you x is equal to negative 5. Therefore, the solution set or the roots are 1 and negative 5. To check, substitute the values of x in the original equation. 2x squared plus 8x minus 10 is equal to 0. Example number 2. Solve x squared minus 2x minus 2 is equal to 0, where a is equal to 1. Here is the solution. First, separate the constant from terms containing x. That is, x squared minus 2x is equal to 2. Next, add 1 to both sides of the equation. So that is, x squared minus 2x plus 1 is equal to 2 plus 1 to make the left side a perfect square trinomial. Next, factor the left side. The quantity of x minus 1 squared is equal to 3. Then extract the square root, giving you x minus 1 is equal to plus or minus square root of 3. Lastly, solve for x. We have now x is equal to 1 plus square root of 3 and x is equal to 1 minus square root of 3. Therefore, the solution set or the roots are 1 plus square root of 3 and 1 minus square root of 3. To check, substitute the values of x in the original equation. X squared minus 2x minus 2 is equal to 0. First, if x is equal to 1 plus square root of 3, then we can have the quantity of 1 plus square root of 3 squared minus 2 times the quantity of 1 plus square root of 3 minus 2 is equal to 0. Applying the special product, we have 1 plus 2 square root of 3 plus 3 minus 2 minus 2 square root of 3 minus 2 is equal to 0. Then simplifying it, we get 1 plus 3 minus 2 minus 2 is equal to 0, resulting to 0 is equal to 0. The other one, x is equal to 1 minus square root of 3. So we have the quantity of 1 minus square root of 3 squared minus 2 times the quantity of 1 minus square root of 3 minus 2 is equal to 0. Applying the square of binomial will give you 1 minus 2 square root of 3 plus 3 minus 2 plus 2 square root of 3 minus 2 is equal to 0. Simplifying it, we'll have 1 plus 3 minus 2 is equal to 0, giving you the result of 0 is equal to 0. And lastly, another way of solving quadratic equation in the form ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers and a should not be equal to 0, is the quadratic formula x is equal to negative b plus or minus square root of b squared minus 4ac over 2a, which is derived by the use of completing the square and finding the square root methods, where x represents the solutions or roots of the quadratic equation A, B, and C are the coefficients of the quadratic equation with A not equal to 0. The plus or minus symbol means that there are two possible solutions, one with a plus sign and one with a minus sign. And lastly, b squared minus 4ac is called the discriminant. The discriminant determines the nature of the roots, and that is to be discussed on our next lesson. The quadratic formula is a powerful tool for finding the solutions to quadratic equations, and it works for all quadratic equations regardless of their coefficients. It is commonly used in algebra, mathematics, physics, engineering, and various other fields where quadratic equations arise. Let's have an illustrative example. Solve the equation x squared plus 3x minus 10 is equal to 0. Here is the solution. First, determine the value of a, b, and c. A is equal to 1, b is equal to 3, and c is equal to negative 10. Then substitute those values into our quadratic formula. X is equal to negative b plus or minus square root of b squared minus 4ac over 2a. So we will have now x is equal to negative 3 plus or minus square root of 3 squared minus 4 times 1 times negative 10 all over 2 times 1. Performing the operations inside the radical sign, we will have x is equal to negative 3 plus or minus square root of 9 plus 40 all over 2. Simplifying it further, we have x is equal to negative 3 plus or minus square root of 49 all over 2. Then, get the square root of 49. That gives us x is equal to negative 3 plus or minus 7 all over 2. Now, we have two possible solutions. First, negative 3 plus 7 divided by 2, which is 4 divided by 2 gives you positive 2. Second, negative 3 minus 7 divided by 2, which is negative 10 divided by 2 gives you negative 5. Therefore, the solution set or the roots are 2 and negative 5. To check, substitute the values of x in the original equation x squared plus 3x minus 10 is equal to 0. First, if x is equal to 2, so 2 squared is equal to 4, plus 3 times 2 is equal to 6. 4 plus 6 minus 10 is equal to 0. 10 minus 10 is equal to 0, giving you 0 is equal to 0. Another, if x is equal to negative 5. Negative 5 squared plus 3 times negative 5 minus 10 is equal to 0. Negative 5 squared is positive 25. 3 times negative 5 is equal to negative 15. So, simplifying it, 25 minus 15 minus 10 gives you 10 minus 10, which is 0, is equal to 0. That ends our lesson today. I hope you learned something. See you on our next episode, mga ka-Acute Angels. Keep safe!